Sound test 1, 2, 3. Hello. Let's go indeed. I didn't touch the task F, so we will not discuss it at all. The plan is to only cover problems A up to E. And for E, I implemented something, like I literally submitted last minute, and I got wrong answer. Hence, as I said, I'm not sure about the correctness. But I think I have, there is a high chance that it works. And if not, then I will try to upsolve live. That is, I will maybe look at the editorial or something. Yeah, for F, I did read it, but I spent like 10 seconds thinking about it. So I didn't even try to solve. Like every day this week, basically, I will remind you that there is registration ongoing for the free classes sponsored by Harborspace, so or provided by Harborspace and taught by me, for Olympiads like IOI preparation. I think it's a great opportunity to learn. So here's the Olympiad classes pasted in the chat. I will also remind about that at the end. Cool. Difficulty comparison in terms of code forces. I think it's harder than Division 2, but easier than Division 1. So I would say Division 1.5. Okay, we want to start. How do I want to do it? Text, and I want to show the name. Okay, let's start. Format point of binary strings. We are given 3 binary strings, and we want to find a balanced string, or a good string, a string that has the same number of zeros and ones, with minimum distance in terms of swapping required to the 3 strings in total. I think this was quite difficult for a Division 2A problem. Actually, it would be fine as code forces Division 1, the Division 1A problem, I think. So a quite difficult start. And here we need to understand the nature of swapping. So this first task A says, first we need to understand distance between S1, S2, that is required swaps. For that, I claim that it's very important what are relative positions of zeros and ones. Pavel used to teach with Harborspace. I don't think he was with Harborspace. It was for some other institution, other university. So if there is a string that looks, let's say, this, and you want from this to get, let's say, this string, then what you could say is that the distance is equal to the difference of position of ones. So this delta distance plus this delta distance, so this distance plus this distance is the number of swaps required to get from one string the other string. Swaps of adjacent characters, swaps of adjacent bits. But sadly, it can be not that easy. For example, if we have something like that and we want to move to this, then we cannot just measure the number, the distance. From this one to this one, we have a distance of 3. From this to this, we have distance of 3. And this to this, we have a distance of 3. So it seems that the answer is 9. The distance between 2 strings is 9, but actually that's not true. The correct... Wait, what? It is true, right? Is it simply true that it's sum of distances? Huh? Wait. I'm surprised. So is it true that for every one it will need to move to the right that many times? It's sum of distances? Okay. Well, that's easy. Oh, then I think I overcomplicated. Okay. I will in a moment tell you my solution. But if we care about, so we are given three binary strings of length 2 times n each. How did I get accepted here? You're given good strings this, okay. Each with n times bit 1, n times bit 0. And we want to create a new string of same parameters to minimize the sum of distances, a to new plus distance of b to new plus distance of c to new. And if indeed we care about positions of ones, we can say that we are focusing on ones, and then in the first string there is a 1 here and a 1 here. In the second there is a 1 here, 1 here. In the third there is a 1 here and 1 here. We want to create such a string with 2 positions of ones in order to minimize the distances. And now we know, it's quite obvious that greedily the first one will move to the first one in our new string. First one from this string will move here. First one from this string will move here. So if we don't know where to put the one in a new string, we should look at the first one in each of the 3 strings given to us. And we need for them to minimize the total distance to somewhere. And it's obvious that the distance should be minimized for the median of those 3 positions. Same thing here. Look at the second one in each of those. And among those 3 positions, you want to get the median. And then the solution is every string you want to read and collect the vector indices where there are bits equal to 1. For that, you don't even type read string 1, read string 2, read string 3. Instead, make a helper function, read, that reads a single string, iterates it, and finds the ones. If s of I is equal this, then some vector pushback I, and return that vector. Now you run this function 3 times and you collect those vectors. So you make vectors a, b, c with those positions of ones, each of them a equals read, b equals read, c equals read. And now you need to iterate those vectors at the same time, and at every position grab the median of 3 values. You want, for example, grab median of a0, b0, c0, then median of a1, b1, c1, and so on. This median will tell you where there should be a 1 in your output string. And I think we need to find this string, right? Yeah, we not only get the distance, but also this. So for each of those cases, we iterate the I, and we say that I want to get position equal to median of those 3, AI, BI, CI. In order to get median of 3 values, you can, I don't know, put them in a vector of 3 elements and sort and grab the middle element. And you want to say total distance plus equal the sum of position minus AI plus position minus BI plus position minus CI, because you know that each of those 3 positions of a 1 in the previous 3 strings, they need to move here. And in the answer string of this position is equal to 1. By default, everything else is 0. Yeah, it happens. I think I overcomplicated because I thought that we need to only look at relative positions for every 1 after how many zeros it comes. And because of that, my code is like that. I have this vector that returns not positions of ones, but the number of zeros. I have those three vectors for which I get the median, but my way of reconstructing the string is slightly more difficult because I put some number of zeros and then a 1. I put some number of zeros and then a 1. It's interesting that it's equivalent. And those solutions should produce, I think, the same string. Apparently overlaps do not matter. So we don't care about overlaps. Even if we have those three strings, in one, let's say, I know there is a 1 here, in the other 1, 1, in the third one, 1, 1. We don't care that in the median string that we try to build, we will put a 1 and a 1 at those two positions roughly in the middle. It's okay, apparently, that the 1 will move here and the 1 will move here. Still, the sum of distances is equal to the total number of swaps. I think you would need to go for a few examples to convince yourself about that. For me, the way I thought about it is that I measure the number of times 1 needs to swap with 0. So my logic is that if after those ones, before those ones, there is nothing. Before those ones, there is 0, 0, 0. So my logic was that each of those ones needs to swap to the right with 3 zeros. This is a 0, this is a 0, this is a 0. And for each of those ones, they need to swap with each of those zeros. That was my logic. And this is not possible. Now I understand your question. Each of those three sequences is sorted. So if you have a sorted sequence and you have, let's say, in a sorted sequence, you have something and then a 5. In another, you have something and then, let's say, 8. And in something, you have something and then, let's say, 10. Median of those three elements is 8. And then if we look at next element in each sequence, then I claim that median of those three question marks is greater than 8. Because here we have at least 6, at least 9, at least 11. So the new median is at least by 1 greater than the previous median. Yeah, that's to answer this question. Or also the thing about overlaps. Cool. I'm happy that people are happy. This is task A. So let's move to task B. I'm putting always the name at the bottom so it would be easier to scroll through the video recording. You are given a sequence, you want to permute it in such a way that for this sequence, every value is equal to number of elements smaller than it before. I will write it down. Given A, permute it so that A of I equals number of previous elements smaller than this element. For example, the sequence 0, 1, 0, 3 is valid because 3 is greater than 3 elements before. Maybe I will rephrase it like that. Definition, this value AI is greater than AI elements before on the left. Okay, that's some rephrasing. 3 is greater than 3 values before. 1 is greater than 1 value before. 0 is greater than 0 values before. Okay, what is a valid sequence then? We need to understand the nature of a sequence that we want to obtain. Only then we will try to permute the input. You can read the blog and comments to get answer to your question. It's not about rating, it's about knowledge and Olympiad experience. This element certainly should be a 0. Now, at some random position, like here, at index 3, the easy candidate is to put a 3 here. If this is a 3, then it's easy to make it greater than previous 3 elements. Actually, always this will happen, that this is now automatically greater than 3 previous elements, because for that not to be greater than something on the left, like here, this would already be invalid. So trivial observation is this. You cannot have 4 at position 2 because it cannot be greater than 4 elements before. There aren't 4 elements before. So this is 2 or smaller for it to be valid. So if here there is 2 or smaller, then this is certainly greater than it. So I will say AI equals I is automatically okay. And let's think what can happen other than those automatic okays. I can put here a 0, I can put here a 0. So there can be a block of equal elements. Actually, this can still be a 0. Can this still be a 0? Well, yes. Can this be a 3? No. After those elements are zeros, then this cannot be a 3. Can this be a 6? Well, yes, it can, because it's automatic okay. It cannot be a 5. It cannot be anything else, because either it's 3 and then this is invalid, or it needs to be just greater also than 3, and then automatically it's 6. Now, what can be here? What are the candidates for next element? It can be 7, can be 6. Also, can it be 3? No, it can be 0. So here, one of those 3 candidates. But we need to understand what other than 7 is generally possible. For some reason, before I had a 0, 3, 6, but here 3 is not available anymore. Why is that? Why I cannot put a 3 here? Because already I used another extra smaller element. This 3 is valid automatically. It's greater than 3 smaller elements on the left. But if I now use something smaller than 3, then 3 becomes invalid. Compare that to a scenario where I keep using here the 3s. This is okay. I can use something greater. And now I can maybe use this again. 3 is still okay. As long as I don't use 0, then 3 is okay. If eventually maybe here there is, 3, 6, 7, 8, 9, 10. 10. Now I cannot use 6 anymore because I used a 3. So using a 3 means that other bigger numbers before become invalid. 6 here was valid because it was greater than 6 smaller elements before. But if you use something smaller, then this is greater than 7 elements before. More generally, if you ever use value x here, and you use value x here, it needs to happen that here there is no smaller value. If there is here somewhere x minus 1, this is invalid. Because if this is greater than x elements here, then this is greater than x plus 1 elements here. So not good. Now okay, so we mostly understand what is possible. Now let's remember that we want to permute the sequence A given to us. So now what happens is that we have access to some elements, like let's say those, and we need to reorder them to make it good. I need to make a sequence of length 4 here. Well, 0 can be here. And now, if I put a 0 here, then I claim that 1 will never be used. This will be bad. Because if I put a 1 here, it's already greater than 2 elements before. So no. If here at position I can use I, then I use it. So as I iterate from, it's normal here to iterate from left to right. And an element is good depending on previous values. So certainly we iterate from left to right. So as we build the sequence, I will say if value I exists, then use it. Use it greedily, because in the future you will not be able to use it. And now what I should use here? First, this is priority. If there was a value 2, I would use it. If not, I need to prioritize using value 1. The alternative is using here 0, but if there exists another 1, then we explained before how this is incorrect. So always I will here prioritize big elements that already were used. Among things that were already used, like here 0 and 1, the biggest of them that is still available, I want to use. Here it's simply a 0 because nothing else is available, and then here a 3. But I think we might get a better example. Yeah, this one. Let's say this is the input. Let me sort it for convenience. So it would be easier for me to see what happens where. Is it more interesting? Let's see. I will build 0, 1 greedily, then 1, 3. Okay, that's stupid. Sorry, that's stupid. But I will modify it now. Let's say 0, 0, 1, 1, 1, 1, 5, 5, and something big I will use. Let's say I want to build this. It will be 0, then a 1 because I need to use it. Then what here? A 2 doesn't exist, so I will use 1. The biggest value available among 0, 1. 1 is bigger, so it's better candidate. A 1, 0, 1, 2, 3, 4. And now I need to use 5. 0, 1, 2, 3, 4, 5. Yeah. Now what I use here is biggest element available, which is 5. What I use here is biggest element available, which is 0. And then if this is index 9, then I would use 9. 0, 1, 2, 3, 4, 5, 6, 7, 8. I could use 8. This is valid. So the logic is that if this, then use that. Otherwise, else use max smaller value. And you needed already to use it before. There is no way to go for some index and not use this value. So this is guaranteed. And I think it can generally be simplified to use max value that doesn't exceed I. I think this should be correct. Use max value up to I. And then you can ignore those. I think this is valid. That being said, my implementation is slightly different. Not always during a contest you can think of all the ideas. So my implementation iterates the input. I don't sort it, I compute frequency of every element, so every value. I compute the frequency array. I don't know if this is needed, but I checked if 0 exists, because 0 needs to be a start. Yes, it's correct? Okay, good. So this should be solvable in linear time. I used a set because I was very lazy. And my logic was quite overcomplicated. I built the answer array. I have a multiset. Always, as I move through the things, at index I, if I exists in the input, then I use it. And I decrease frequency by 1. So if I had 5 occurrences, now I have 4 occurrences. I will explain that in a moment. And now else, I use the max value among things that already were encountered in terms of values. And for that, I have multiset of those remaining occurrences of smaller elements. For example, if in the input there are 5 zeros and I use one of them, then the remaining 4 zeros I insert into this multiset. That seems overcomplicated, really. And now I see that we keep increasing new elements in increasing order, so this shouldn't be a set, it should be a stack or a vector where we always take from the end. I didn't understand that while solving. So yeah, but what I did then is when I start a new value, like I'm at position 5, I put a 5 here. The remaining occurrences of 5 I put into my set, multiset. Well, it should be a stack. So this instead should be those remaining occurrences put in the stack. And here there is this if else I put the last element of the stack. That would be enough. And I mean, I think you're right that we can simply do this logic, which is just put all the input elements to one multiset, and for every I, you can use upper bound and then minus minus in the set. So I think that this should also be correct. This is the input values, and here grab the S upper bound of I, and then iterator minus minus if this is not S dot begin, and here we use that. Answer pushback this and set erase IT. Just add ifs for checking if indeed this is an existing element. This sounds correct. If somebody says an issue, please confirm. But you know, not always in a contest you will get simplest solution. I had some path of my logic and this is what I implemented. Any questions? For C, well, let me first maybe put the name. For C, I mostly work with my intuition. It was a little bit of guessing for the solution. Okay, what it is we have a circle with letters. Initially, one person stands at every index, and repeatedly we choose a character and everybody moves clockwise to the next occurrence of such a character. If possible, we want to get everybody to the same position. If not, we need to still minimize the number of distinct positions where people will be. For example, let's say that in this cyclic order we have A, B, A, C, A, B, C, C, B. Initially, there is one person everywhere. But I tell all of them to move clockwise to the next occurrence of A. So for example, this guy will move here to the next A. This guy from here, they still need to move by at least one position. So this one would move here. After one here, for such a start, if I first choose A as your first move, then everybody will be just at those 3 slots. It doesn't matter how many people are at every slot. Now I have some choices of what to do. I can choose for all of them to move to the next B or to the next C. If I decide to move to the next B, this guy will go here, this will also go here, and this will go here. So now new situation would be like that. Now I can move them to the next C, then they will be here. I can move to the next B, they will be here. And I can move to the next A, and then they will be here. And I got everybody to this position, I think. I will move back for a moment. When I'm here, so I moved first, I used A, then I used B. Now from B, I will use C. This guy will get here, this guy will get here. So now I'm here and there. Now I will use B. And as a human, I know that I'm doing that because now if I'm at those 2 Bs, then both of them lead to the same A. So B and A. That's a valid string of operations to get to a single position. You don't need to minimize that length. Also, the length of the input is small. Let's follow the letters. So n is up to 1000, and you need to produce any string of at most 1 million operations in order to get them all to the same position, or to the minimum number of positions possible. And here what we did is, at some point close to the end, what I understood is that if for A there is some range of positions between 2 consecutive occurrences of A, then if I get to 2 slots that are in the same range in terms of A, then I can unify it. That's, I think, first thing that I thought. That being said, I didn't use this understanding. I didn't use this observation. Maybe it leads towards somewhere, but I think it doesn't help in doing the operations before. Maybe it helps doing the last operation ever, but before that it's tricky, right? You might need to do several operations, and only then it will be possible to unify something. Okay, I also had idea, likely invalid, is that we will get limited number of states, few states possible. What is a state? A state in this process, in this game, is a bit mask of at what positions we are. Initially we are at all positions, after a moment we are at positions of the single character and we keep moving. And my first thought is that we do something like DFS or BFS, where our state is bit mask, current bit mask or set of indices, and we consider all 26 moves. The alphabet size is 26, so I consider all moves. I move to some new state, and we have this, and I will say maybe this is exponential. I don't know. Later you can check in editorial, or you can ask ChatGPT, and maybe you will get information whether this is exponential or not. I do not know. Okay, then some other idea, and I will say likely correct, valid, is it's more like lemma, is that you can make moves greedily and it will not mess up situation. So maybe I will say maybe correct lemma is making a move doesn't hurt. You will never get to a situation where you cannot get back to what you had before, or you will only get to better situations. So I will claim that I think it's correct. I will again say maybe correct but slow solution. Keep making moves at random. I don't know how fast it converges, and I didn't implement that, but it seems simple enough that if I didn't have other ideas, I would implement that. Actually, let me take a quick look at the editorial whether they mention the word random, or do they have my solution? Oh, okay, the solution is completely different. Okay, we will move to the editorial. From consecutive same characters, you can move to another index, moving all people to one person. This would only happen if in an edge case. Okay, I see. So maybe in a moment we'll move to editorial, because I see that it is basically a string problem, which also came through my mind, but sadly faster I went to something more complicated. So let me discuss my solution. I think it's educational. I hope it's correct. Well, I got accepted, okay, but I hope it's correct. It's not intended. So I shared some ideas that I tried, but I don't know about them. And now here comes my solution. My solution, not intended, is that if there are n people and you want to unify them, for every pair of people, if they are right now at different positions, I will make such moves that they will be at same position. So if you track n people, what is valid, I hope, is for every person I, for every j, if different positions, move to same position. Come up with such series of moves that those two will be in the same position. And thus the number of distinct positions decreases by 1. And whatever series of operations I find here to achieve that, I will apply to everybody else. All the n-2 people I will modify. And because n is up to 1000, the number of times that this will happen indeed, and here I will say apply these moves to everybody. If indeed you succeed, that is for 2 people, I realize that they can be moved to the same position, and it's hard to check that, then I claim that this can happen n-1 times at most. Because after every time you succeed with this, 2 people get to the same position and they will remain at the same position. Now, this relies on 2 things. One is that there is this lemma of making a move doesn't hurt. And second is I want to be able to move two people at the same position. So let's try to understand what we need here. Given our circle, given two positions I and J, I want to find a series of moves, at most k moves I hope, such that they will eventually get to the same slot. So maybe I move this one here, then maybe I move this one somewhere, and then maybe from this I move them to the same slot. Well, there are n squared pairs of positions, so I can try all possibilities as pre-processing. And I will what I did is I ran BFS backwards. So think about it this way: number of every pair ij is the current state or the current node of a graph, and you want to get it to something like x comma x. And let's say we want to use small number of moves, so BFS. What I did is I created this graph with n squared nodes. I created all the edges backwards. So actually I will want from something like that to get to my pair ij, and I wonder what is smallest distance from some pair of this form to my ij. And also I will know the letters that allow me to achieve that. How do I create this graph? Well, for every pair of positions, so maybe initially, let's say I is here and j is here. There are 26 possible moves, 26 edges of how I can do one operation from here to somewhere else. That is, I can use A, B, or C, one of the characters. If I, for example, decide to use A, the character A, then from here I will get there, and from here I will get here. So this is some kind of I2, and this is some kind of J2. Then I make an edge from pair ij. I make an edge of cost 1 to I2, J2. Actually, I will move on backwards graph. So actually I make such an edge. And I will run BFS in reverse. So there are n squared nodes in my new graph, n squared times 26 edges, directed edges. And I want to, the states like those. This states with distance 0. And from all of them, I run multi-source BFS. Multi-source BFS. This way I will get distance to every other ij. My intuition told me that the distances will be up to n. I don't know if that can be proved. And yep, that's what I did. Finally, how do we actually find edges quickly? So for every pair ij, I have 26 moves to consider. For that, I need to quickly know in clockwise direction where is the next occurrence of every character, like next A. You should pre-compute that in a separate array, and you should make sure it works in cyclic order. Good morning. I want to show you my code because I think it's educational, even though it's not the intended solution. I grab only the characters that exist, because maybe not all 26 characters exist. I double the string. It's a common trick. If you have if you want to treat a sequence or a string as something cyclic, then you attach a copy to it. If the input is ABCD, then you add another ABCD. Now you have a string of length 8, and you work with that. Now, easily, linearly, I, for every position, find the next occurrence of every character. I could even do it with a brute force, but for that you go from right to left, and then for every position you just copy information from the right neighbor. That's easy in n times 26. And I use here positions modulo n. So it can happen that I will know that for index, I don't know, 6, the next occurrence of A is equal to 2. That can happen because in clockwise order, maybe after 6 you go to n and then you go down to 0. Okay, so easy pre-computation, quite standard. Now I create, whoops, I create the graph. I have n squared nodes, and for each of them I want edges. So I want edges of ij is edges that go out of edges out of node ij. And here for every pair ij, I didn't bother with those two being the same node. That doesn't affect time complexity, but this can be certainly faster by 2 because ij and ji are the same. And for every alphabet character up to 26 possibilities, I grab what is the next occurrence of this character clockwise from j. I have I to j2, and I put an edge backwards because I will want to run multi-source BFS from all the final states, those with distance 0. Yeah, but yeah, sorry, I messed up. Here we go. No, sorry, but you can, there will be some stuff on YouTube. There will be parts of it on YouTube. Okay, so we have the graph, and now we have multi-source BFS starting from the states I, I. So that's BFS. Then I create helper function for ij. I want to know what is smallest number of steps to move from ij to the same position, and I want to reconstruct that path. For that, when you build the graph, where is it? Here. When I build a graph from I to j2, I put an edge to ij, but I also save the character c. And it's like breadcrumbs. Or maybe, sorry, I should say here, those were the edges, but this is the parent array. If in BFS you want to later reconstruct one of shortest paths, you put parent array so that for every node you would know from where you came and also the character that you used. Normally what we then do is from some node, if you want to get somewhere, you backwards reconstruct that path and then you reverse the characters. But here we don't reverse because we already operated with a reverse graph. Actually, I made a mistake and I got wrong answer because I unnecessarily reversed, even though the graph is reversed. I don't think it's that easy. I didn't come up with a solution in 1 minute or 2. I was surprised by the difficulty of the contest. Okay, and then we start with all the n positions, and for every pair ij, j greater than I, if right now they are not on the same position, then I move them to the same position. I get the path that will move them to the same position. I think the way I implemented that is, even if they are on the same position, I will get that path. It will simply be empty. And yeah, I add those characters to the answer. If path not empty, I apply it to everybody. Okay, and I think it's not necessary, but I updated my vector of positions. So if my vector of if initially I know, let's say, that everybody is at those positions, then I make them to be the same position. I think I could put them and make everything still be of same length n. So maybe I decided I want to remove one of those occurrences. I don't know if it's needed. So what I did is here I erased the jth object, and then it's easy to make a mistake. And actually, let me focus on that. As you iterate objects of a vector and you erase an object, you want to do index minus minus so that the next object would still be considered. For example, if I have objects called, let's say, a, b, c in a vector, maybe let's say x, y, z in a vector, if you, let's say, merge x with y, you manage to make them equal, and then you erase y, then your index j will still point to that same position, and if you let your for loop iterate onward, j then is here, and you will never consider the pair xz. Hence, if you do this stupid solution that I did, you need to here do index minus minus. If you don't understand this fully, please later analyze it some more. Why this is incorrect without the line j minus minus. Okay, and then we do this. Time complexity is n times 26 pre-processing to find next occurrence of everything. Then for each of n squared states or pairs of indices, I have 26 possible moves. That's size of the graph. Then I run BFS here, which has this time complexity. And finally, for each of n squared pairs, I consider it and I say pairs of people. Initially, people are at different positions. If they are at different position, I try to do something. So here, this times, I just, for each of those pairs, I simply check if in the BFS graph, the distance of something is not infinity. If distance of ij is equal infinity, what this means is you cannot get people from positions I and j together. They will forever be at different positions, no matter what you do otherwise. And otherwise, if distance of ij is equal 5, this means you need 5 moves, and you get those 5 moves. How to get people from those two positions to be on the same position. So most of the times this will happen, but at most n-1 times, you will actually manage to merge two people. And for each such time, you need to iterate each of n people, and you want to here iterate something. For each of them, you is this n cubic? For each of the people, you actually apply the moves. It's not guaranteed that everybody ends up on the same island. I mean, if that happens n-1 times. Then yes. I think that I described n-cubic solution and the tests are weak, because now that I think about it, n-1 times you will manage to indeed merge two people. If you do, then you get a path of d characters and you need to apply it for all the n people. My theory was that d is up to n, and then what we have is n-cubic. But I think that I can claim that n is up to 500. So this is still a reasonable solution. So this might be too slow. I didn't do this. I didn't observe the full time complexity. So this sounds like n-cubic. But n is up to 1000, but we can think what happens after the first move. If we have a cycle and we choose the least appearing character, let's say A appears 4 times, B appears 3 times, everything else appears more times, then let's say I move to B first, then I will be only at those 3 slots. I claim that after the first move, if we choose the least common character, we have some kind of n prime up to at most 500. The pessimistic case is that there will be 2 characters that appear same number of times. So then immediately my vector is of size 500, and at most 499 times I will update, and every update I will need to update always only up to 500 people. So actually this is 500 times 500, and because I erase from my vector, it's more like the first time I need to update all the 500 different people, then 499 and so on. So this actually sums up to n squared divided by 2. So this 500 squared divided by 2. And then d still is up to n. So I think I showed how this is actually something like 1000 cubic divided by 8 or so. Or in other words, something like this. Maybe divided by 4. And this should be okay. I mean, yes, but alphabet could be 2. And well, yes, alphabet could be 2. So it's tricky to say it's n divided by size of alphabet, because 26 is not really worst case scenario. No, you're correct though. Here I can say n divided by alphabet, and same here. Those two are both n divided by alphabet squared. Yeah, interesting. I wonder if I think that my solution cannot be broken, cannot be given time limit exceeded. But yeah, it's embarrassing that I described something that I thought is quadratic, but it's at least cubic, it seems. Now, for the intended solution, let's briefly take a look. Also, what is, where's my submissions? If you ever want to see my codes, you can go to results, all submissions, and you can search for my nickname, and then you will find my submissions to a given contest. I got 600 milliseconds out of time limit of 2 seconds. But I assume that building n squared times 26 graph, it creates a lot of memory, and just assigning that memory takes that time. I'm guessing that it's not that, it's really from the n cubic part. Okay, and now the editorial. The answer to this problem is the number of repetitions of the period of S. This number of I, for example, this. Okay, so if the input string is something like this, then you don't really have anything to do. If you use A, then you will be here and here. And then if you use whatever, then you will be just shifted. And that's it. And apparently the claim is that if this is broken in any way, like so, then you can always get to a single position. Oh, I see. The solution is to repeat S n times. If that's the case, then I think my idea with random moves also could have worked. Interesting. Well, where is K found in your solution? What is K? Oh, I mean, K is the final vector size. Right? My logic is, while I can merge two people at distinct positions, I merge them and I erase the repetition. I maintain positions of people in vector all. At the end, I print the size of this vector. Answer is the string. So I also print it. And whenever I have some path, I add to the string this path of characters. Well, yeah, if you want to break my solution, you also need to make sure that those paths are long. For two people at some random positions, you want to make it necessary to do a lot of moves before they converge. And you want to make sure that other people do not converge at the same time, otherwise the solution will be fast. So maybe it can be proved that this is n squared. I don't know. Okay, you can read the editorial for all the details about that easy solution. So please note, what I described, while I think it's educational, it's way more difficult than the intended solution. Wait. Oh. Yes. All is a vector of positions. I lose information about initial indices, right? If initially people are on those positions and I merge those two guys, my new vector might be, let's say this is at 3, this is now at maybe 0, this is at 1, this is maybe also at 0. The index I really is not correct in your statement, because by erasing I shifted indices. So this vector, it means that there is a person on index 3, there is a person on index 0, person on index 1, person on index 0. I don't maintain really which person is here. So erase destroys information about indices I. Okay, well, I overcomplicated. Let's move on. The median of binary strings. This is first of two tasks today that I misunderstood. The task says that you're given binary strings. You can choose 3 of them and write their median as another string. I thought that we erase the previous 3. I thought that we take 3 strings and we change them into a new one. That's invalid understanding. What happens is that we add a new one and we keep getting more and more strings. So I wasted some time because of that. I think that here they should, in code forces, I think they would write in bold, we don't erase the previous 3 strings. Okay, and what do we do? Always we take 3 strings, and when we want to merge them into the median, well, not merge, I want to add a new string. At every position, I grab the median of the 3 position of the 3 bits. 0, 0, 0, 0, 0, 1 give you a median of 0. And this way you can build a new string. For example, if you're given, let's say, something like this, something like that, all the ones, maybe also this, what you keep doing is you choose 3 strings, let's say this one, and this one. You now focus on them, and let me for a moment write it down below. I chose this guy, and this one. And at every position here, I write the median of those 3 values. 0, 1, 0 have a median of 0. 1, 1, 0, 1. 0, 1, 0, 0. A 1, a 0, and here a 0. Okay, that's the result. It here is very similar, by the way, to this guy, but different. And now the statement says we add this, and now we have new thing. The task basically says that we need to understand what strings are possible. But actually, in terms of constraints, let me not mistaken the things. Okay. You are given n up to 500 binary strings of length m up to 500. There is the same length. And then you are given q queries. Can this new string be obtained? And you need to say yes or no. It's not really important here, this value of q. It's very difficult to solve it for a single query and in any polynomial time. So it would be even challenged with n up to 50 and a single query. Okay, because it's easy certainly to do in 2 at power m, where you try to build different strings. Now, I had a lot of invalid ideas here. I had, for example, an idea that it's enough to, I tried to think about it this way. With such n, I can iterate triples of initial strings. Maybe with bitwise operations, for 3 strings, I can quickly compute what is the result. And I had invalid lemma that it's enough to consider, say, every f s of I and every f of si, sj, sk, where f is the median operation. And I had this lemma or intuition that maybe we don't need to continue this. This result, I don't need to merge with other results or with other strings, because maybe you will only keep getting the same things. I hoped that this is true, because then I saw a hope for a fast enough solution. Actually, it would be n4 divided by 32, but maybe can be improved. And actually, even what I did during the contest, this is task D. Well, no, sorry, I erased my code. Okay, what I implemented is just a check of generate random input, save in a set all the input strings, all the results from triples, and then make sure that if you now run the f function, the median on random now triple, it is already in the set, that you are not obtaining something new. And suddenly I quickly got a counter test, so no, this is incorrect lemma. But I was able to verify it in, I don't know, 4 minutes. I don't think it even took 5 minutes. So this is not correct. Right. So what? I'm bothered by this scrolling thing at here. Can I move this here? Why does it let me scroll? Well, we need to live with that. What do you do to prove lemmas and ideas in contest quickly? Intuition, math skill, and also sometimes a brute force, like here. I didn't know if this is correct, so I wrote a program to check for random data. If it works on thousands of random tests, I'm assuming it's correct, but here, no, it didn't work. Okay. Then I spent a lot of time, and actually I kept jumping between this problem and the next one. So for a long time I couldn't solve this. Then I had some idea that also initially I thought is incorrect, then I needed to get back to it. Maybe we can build the target string from left to right. That was my idea. Also, for simplification, let's say that the query is all ones. This helps thinking a lot. It's way easier to think if this is the target, because I want to prioritize input strings with a lot of ones. Actually, also incorrect is look at number of ones or number of matches with target string. That doesn't make sense. I also tried thinking that every 0 should be treated as -1, every 1 is +1, then we look at the sum of values, and maybe this will be useful. I'm happy you like my stuff. So let's say this is the query, and there is input. Let's say the input is, right, well, I will start with something that has at least one at the beginning. Maybe it doesn't need to be so long. I want to then get a 1 on the second slot. Well, if there is another 0, 1, and then zeros, and another 0 and zeros, by medianing those 3 strings, I can get a 1 on the third slot, but I cannot get it on the first slot. But actually, if we have this string with 1, 0 at the beginning and only strings of this form, then I can never get those 2 ones, right? If this is the input, if it's just this and something, if it's this and something, this and something, there are no 3 strings that you can choose so that you would get a 1, 1 on the first 2 slots. If you choose such a triple, you will get 0, 1. If you choose such a triple, you will use 1, 0. If you use something like this, this, and that, it's the same thing. Obviously, it doesn't help if this is the situation. So what you need is also a string that will give you a 1, 1. Now, if you have such a string, then obviously you could start with that. So let's say, yeah, we start with that. And now I want to continue building. I want to have a 1 here. Maybe, so initially, let's say I start from a string that has longest prefix of 1s, assuming that this is the target query. Maybe I will say target query. Now, I already explained how if other strings are only of those forms, then I fail, because I never can get a 1, 1 here. But let's say there is something with 1, 1, and now I want to merge this with a third thing that will allow me to keep this 1. For that, I need a 1 here. I don't care about this. And I need here 0, 1 and something. I need a 1. By the way, it doesn't make sense to use some string twice. It was allowed in the statement, but if you twice use exactly the same string, then the result of median will be exactly the same string, right? F of x, x, y is equal x. So you're not getting something new. You always need to choose 3 distinct things. Now, if I choose such 3 strings, then the result will be 111 something. Let's do one more iteration of that. What I need is a 1 here, and I already explained how having a 0 here is not enough. I need a 1 here. Now I also need 0, 1. This is how you can get ones on those 2 positions, but well, I also need something here. But my logic of building this string can be repeated for other subset of indices. If I go through the string from left to right and I prioritize index 0, then 1, then 2, I can build this. If I actually look at indices 0, 1, and then 3, I can similarly build this. So let's say this. I build this. I build this. And I need this in the input. S of I in the input, one of the input strings. Now, if indeed I'm able to build those, then now I can obtain 111, this. It's like proof by induction. For every 3 indices, if you can indeed obtain the triple of ones at those slots, then you can combine such 2 things to get ones on 4 slots, assuming that this exists. And now to formalize this a little bit, for every 2 positions, you want a string of this form in the input. For every pair of indices, ij, there needs to be input string s, such that s of I equals s of j equals 1. If that is not true, else nope, you cannot get it. Still, we are talking about obtaining target query of only ones. The proof for this, why else it's impossible, is that if only strings have a 0 here and 1 here, or a 1 here and a 0 here, there is no combination of some such strings that they will give you a 1, 1. Not consecutive. If you can build 3 ones at some positions for every triple of positions, then you also can build 4. But I will also claim that it comes from just pairs. And also, I guess that using the constraints and time complexity. So now, natural guess from this is that, but if this is true, if so, then yes, else no. This is easy to prove. This was more of a guess for me initially. But now it comes, the proof for that is exactly the construction that we're doing. So if for every pair of indices in the string, there is an input string with indeed the 2 ones here, then I claim that I can build this. Because that means there is something that looks like this, there is something that looks like this, there is something that looks like this. Combination of those will be 1, 1, 1, and so on. So this shows how if every pair ij exists, then every triple ijk can be done, can be built, and so on. And then 4 tuple, and so on. But mostly I thought about it from left to right. So generally, if you can build this, and you can build this, so it's induction. If you can build every string with k indices equal to 1, and also there exists something like this in the input, then combination will be k plus 1 once. Intuition of checking every pair. The intuition is that when trying to build things from left to right, I realized that if for some pair there isn't any 1, 1 in the input, then it's impossible. And that's easy part. So this, you can even work with length equal to 2. If the input only has those, then you can never obtain this, right? No matter what happens on other indices. The guess was that also it's equivalent. That is, if you have a pair of ones, then it's possible. Is it okay if I read the tutorial a lot when doing 2000 plus problems? Very well. Yes. I think after you're stuck for a long time, you should take a look at the tutorial. Do not fully read it. Take a hint from there. I mean, you know, it was hard to think that you need to do it from left to right. I spent a lot of time on this task, honestly. Okay, so for the target query like that, it's enough to check if in the input every pair of positions is covered as a 1-1. So generally for a single query, what you can do is iterate all pairs ij, iterate everything in the input and check if there is a string with the matching things. But now to make it fast, because, well, you don't want this. For every query, you cannot iterate all the length squared pairs, and for each of them iterate the full input, their n strings. That's too much. This is 504th. Nope, too slow. What you want to do is some pre-processing. For every string in the input, for every pair of positions, you want to save information. There is a string that has a 0 here, 1 here. So if ever there will be a query that indeed looks like this, so this is query, where I check if for such pair of indices something in the input matches that, I need to check that in constant time. So as pre-processing, I have this. Well, length by 2 by 2 for every pair of indices and for every requirement for the first bit and the second bit, whether there is input string that has that. I think it's easier to think about ones, but generally if there is a 0 here somewhere in target query, then you will need a 0 there. But now the code is trivial and it's cubic, obviously, because I make that array 500 by 500 by 2 by 2. For every I don't even store the input strings. For every input string, I read it. For every pair of positions, including the position with itself, for simplicity. I wasn't sure if that's needed. So I allow I to be equal to j. I say that for this pair, those 2 bits can be done, right? If I see a 0 here and a 1 here, then I will say yes of I, j, 0, 1 is equal true. And now for a query, I read the string. I need to basically check the same thing. I copy paste this, by the way. I again iterate every pair of indices and I check if yes, if in the input somewhere there was a string with such a pair of values at those positions. If not, then Boolean flag OK becomes false, and depending on that I say yes or no. Right. So if there is a query that looks, let's say, like this, you look at every pair of positions. For example, you look at this, and if in the input there isn't any string that looks like this, then you say no, not possible. Otherwise you say yes. Uh, 5 minutes? I mean, maybe he understands your situation more, but I think at high enough level 5 minutes is absurd. You can be stuck on for 5 minutes and then get an idea. I don't think 5 minutes of not coming up with something new is being stuck. So I think it should be longer. By the way, Umnik says that you should never look at editorial, so you should spend days on a problem, so you can leave it and you can get back to a task. I think that you should take the average of those two approaches, which is like, you know, spend some time, maybe after 20 minutes at least, on an easy task, or 40 minutes on a hard task. You then look at the editorial for a hint. Okay, so easy cubic solution, of course. It's trivial because we have 3 for loop, so 500 cubic with a small constant factor. Any questions? Okay, and now this is tricky because in E I didn't get accepted. I got wrong answer, and I don't know, it's possible that I made a mistake in my code. It's possible that I just got a completely incorrect solution. I needed induction for the proof. I wanted to say that any set of k indices we can get if we can obtain any set of k minus 1 indices. Okay, here. We start from a binary string with a lot of zeros and a single one at the first position. And there are m switches. Each of them you can press, and it's some value such that in your binary string, you apply some operation. Each switch can be pressed 0 times or once. And at first, I didn't read this. I thought it's 0 times or more. This should be in bold. So here, every switch can be pressed or not, but you are not allowed to do it twice, which completely changes the problem. And what's ugly is that the first two samples do not show the difference between that. So only on the big sample it's clear. And yes, we start from pairs. From that we get triples and so on. So here I passed this sample, so I think my understanding, I got accepted on some tests, including all the samples. So I think my understanding of the statement is correct. Basically, it boils down to this. We start with just such a number of fixed length. The length is n. Length n. And there are m values available to us, m values ai, saying that if this is our number x, what we do is x or equal x shifted by ai. And then, how is it called? Truncate? Cut down to n bits. For example, let's say that, maybe even shorter. If we have this and we use some AI, switch AI equal to 3, what we will get is this. If now we use some other AJ equals, let's say 2, what I will get is this. This one would actually propagate to the left, but I'm out of the number. We always cut down to length n. Actually, in terms of binary operations, this follows with this. Okay, that's the statement says that if you decide to use AI, you do those two things. Okay, and now let's say AK equals 1. What will happen is that this will move to the left. Those two will cancel, so a 0. Then this one stays, and this will propagate. For example, those 3 operations will give you that. Now, quite quickly, what do we compute? The task is that you want to compute the number of possible final binary values. Count possible final values. After pressing some switches, you can each switch press or do not press, and you can do it in any order. Almost immediately, I got the idea that order doesn't matter. That whether you do it in this order or you do it in operation 1 to 3 or 2 1 3, it doesn't matter. For the small samples, it was true that it doesn't matter. For some samples made by hand also it was true. And then what I did is I wrote a brute force which can I show it? Oh yeah. So what I did is in infinite loop I generated random x, the binary value, I generated two random AI values, two random shifts, and I applied them in two different orders. I asserted that the result is the same. So that was my logic. The order doesn't matter, so it becomes a lemma. I don't have a proof. I'm sure that it can be done with math in 5 minutes. Once, for me, implementing brute force took, I think, 2 minutes. So, and I was then sure that it's correct, unless I have a bug. So it was faster for me than instead thinking about a proof. Though sometimes understanding a proof with math rather than proving it with a brute force, sometimes really understanding helps in discovering the full solution. Anyway, now I know that the question is simply what subset of input values I can use. So the answer is limited by 2 at power n, right? If n is 2, then the answer is 4. If n is 1, the answer is 2. It's just a subset of which values AI I use. But sadly here the n is 30 and this is not 2 at power 30, also with modulo values, because using different subsets can give you the same final value. But I actually had another lemma. So let's write down the statement. There is n length in binary. There is x equal to this, number of length n. You are given array A. You use subset of it. For each chosen element, let's say AI, what you do is x or equal x shifted by AI, and then cut x down to n bits. So you don't care about bigger bits. You can do that with binary operations. And then the question is how many different x values you can get. Modulo something. The lemma was that subsets are enough to consider. We don't care about order. I'm going to now look at the editorial whether they confirm that, because I don't want to continue with some bullshit. The order doesn't matter. Okay, and there is some proof, sure. Now, I had another lemma. Well, the length of a number is very important, I think, especially for repetitions. Okay, another lemma. If AI is distinct, then answer is 2 at power n. I'm going to again maybe look at the editorial to check if they confirm, and then I will tell you my intuition. Yes, I know that. Oh yeah, they claim this. Okay. Fine. Why I thought this? Well, yes, but I'm not sure yet about format or schedule. I will think about it. Still with Harbor Space, we're discussing details of this partnership, what is best for me to do. And yeah, we'll see. Okay, why is that? Well, if you have a number like this, no, if you look at some number x that possibly you can obtain, can this be obtained? If values AI are distinct, then in particular the smallest bit, this bit always needs to be on. but this is like smallest AI used. Uniquely we can determine that, because bigger values AI only affect things more to the left. Maybe so that you would understand this better, let's simulate. Actually, I did simulate before. Okay, never mind. So I know that this is used. And let's think about, well, I can basically cancel that. Maybe that's not fully correct, but I already know this, and then I wonder what is the second smallest AI value. And for that, as I continue, I know that if only this was used, then this would be all zeros. Maybe I will use this. And if you see another one, you know that another AJ was used. And in this simple case, you would... Okay, this is invalid. Well, here I know that AI is equals 2 was used, and also AJ equals 5 is used. And because of that, also 7 is positioned with value 1. Now, how do I describe my intuition? Okay, I know. As you move from smallest bits to biggest, for the elements that you already have will tell you, and you don't even come up with the logic, but they would create some value of X. For just 2 elements, it's trivial. It's just here, what is possible here to obtain is the position 0, position 2, position 5, and 7. By the way, always the resulting string X, what it has is, if you used some values AI, then in X a bit I or bit J is on if it can be obtained with a subset of those values. It's a sum of subset of chosen AI. Then this basically changes the parity of this bit, and there is odd number of such subsets. So things cancel out. For example, if you use A values equal to, I don't know, 1, 2, 3, then you look at the sums which include 1 plus 2 and also 3, and they cancel out. So at position 3 we will have a value of 0. Anyway, you don't even need to understand that, though it's some intuition. I claim as we move from smallest to biggest bits, the values that we already decided should be used, then they determine all the bits. And whenever you see the disparity, so with that logic, that should say that there is some string. Whenever you see something that doesn't work, it means that you've now discovered a new value AK. And we don't need to implement that logic. This is just the explanation for this. For every new bit, if the previous bits do not properly explain what it is, then it means that this is a new value AI that was apparently used. So from every X, we can uniquely determine what values AI are used. Hence, indeed, every subset will produce a different string. No two different subsets will produce the same string. And maybe to give you an example, let's say that I have some X. No, I'm too lazy. It would take a lot of time. Like at least there needs to be at least 3 elements. There will be 8 sums. No, I'm too lazy. So now we have this. And I know now that only there is interaction between equal elements. And now it's very important that if you use AI equals something, let's say 1, and then another A of j equals 1, they kind of cancel out. And they behave the same, not cancel out fully, they behave like a value 2. So if you have this and you apply shift of 1, you will get this. And now if you apply shift of 1 again, what you will have is this. So using a 1 twice is equivalent to using a single 2. Because of that, there will be interaction between values AI and other values that are twice bigger. For example, if in the input, let's say that input array is equal to, let's say 3 appears that many times, then there is a 4, then there are maybe 2 5s. I claim that here it's easy to compute the answer, because assuming that the length of this binary string is big, I claim that I can use any number of those 3s. I can use 0 of them, or 1, or 2, or 3, or 4, or 5. So there are, the frequency of 3 is that 5, frequency of 4 is 1, and frequency of 5 is 2. It's like counting number of divisors once you have factorization. If you have 5 3s, you can use from 0 to 5 of them, so it means that there are 6 possibilities, multiplied by 2 possibilities to take a 4 or not, multiplied by 3 possibilities of taking 5s. But the issue comes from the fact that we have a limited length of the string x, so we cut down the big bits. And also the issue happens when we have a number that is double of another number. I claim that we should look at them at the same time and do some logic in total. Now, I think it's easy to make a mistake here, and maybe I did, because again, I got wrong answer, so I need to figure out what is wrong. What I did is I grouped together things that look like this. For example, if I know that there is some number of values, maybe frequency of 3 is equal to something, frequency of 6 is equal to something, maybe 12 appears twice, maybe 24 appears 0 times, but maybe 48 appears 10 times. I need to handle all of this together. Those elements interact with each other. Using 12 twice is equivalent to using 24 once. Actually, now this number couldn't get to this value, but now they would. Using this 4 times is equivalent to using this once. In order not to double count, what we need to say is power of 2. Power of 2. I look at x, 2x, 4x, 8x, 16x. At least that's what I did. Surprisingly, there isn't really interaction between x and 3x. And just briefly, that's because if you use a value, maybe if you use value 1 twice, I explained somewhere, or maybe I erased. If you use on this, if you use 1, you get that, and if you use it again, you get this. But if you use it a third time, you get this. Now, this is equivalent. We could use AI equals 2 instead. But this is not equivalent to using AI equal to 3. Also, later, if I use again, if let's say this was longer, then what I would get is this. No, that. Yeah, so using 4 times, is we could use AI equals 4. If you use twice more, then what you will get is this, and then I think that. I hope I didn't make mistakes. So only at powers of 2 you have something equivalent to using a bigger thing. Anyway, we need to consider this all at the same time, and in order not to double count, I will use the following logic. Maybe for a moment let's do this because it will be simpler. I'm not allowed to twice use a 12 if I still can use a 24 instead. So I only want to count such possibilities of how many times I use each element, such that I don't see a situation where this I use twice and this I use not max number of times. I will say that if this is true, then instead I want to count this taken 0 times and this taken once. So I want to count such sequences of length 5, where the first element is up to 5, second up to 1, third up to 4, and so on, such that there isn't any value that is greater or equal to, and the next value or anything later is not fully used. And this is either simple math / combinatorics, or could also be done with DP. The dog wanted to come to the room. Sometimes he scratches the door and wants the door to be open. Right. Oh, and another thing is that there is length of the binary string. Actually, once you have the sum, what this means is that we have those numbers in the input, and as we choose some subset, we will get the sum of chosen elements. I claim that once we exceed the length of this, what happens further doesn't matter anymore, because we are not able to distinguish there. We don't have information after this that something happens there. Right? Yeah. Actually, wait, does it matter? Let's see. For example, if this is the number and I use AI equals, let's say, 4, if I decide to use it once, I will get a 1 here 4 units to the left. If I use it again, then there is no element here. This one would get a value of 1. But using this twice will actually give me back this. So I'm only interested in the sums that do not exceed the length of this. Actually, the distance from here to here is 7. So if the length was n, right? Yeah. So I want to count only subsets with sum up to n minus 1. Okay, because otherwise that sum starts affecting bits that we don't have access to. Okay, in other words, what we want to achieve is this. As we look at numbers that are of this form, x, twice x, 4 times x, 8 times x, and so on, numbers that have some interaction between them, we know each of them how many times it appears, like maybe this. Then what happens is that we consider this represents a part of the input with elements 3 appearing 5 times, then a 6, then 12 appears 4 times, 24 appears 3 times, and so on. This is this part of the input. There turns out, surprisingly, that there is no interaction between this and other elements in the input. Something like that, yes. But I will get back to this. And I don't use whiteboard, I use paper. For example, I don't know if you will see or my camera will destroy it. Those are my notes from today. It's a lot of zeros, ones, and some graphs. Maybe also, I don't know if this is from today or not. Just a piece of paper. I want to here count, the task is count subsets of this with sum not exceeding n minus 1. And you cannot take value x twice if you could instead could have taken twice x. Similarly, I wonder if this is what I messed up. You can't take x 4 times if you could instead take 4 times x. Actually, I think that I didn't consider this in my code. Maybe that's the reason. And the samples are not that strong. The samples have interaction between a number and double it, but not between 4 times it, and so on. Now, getting to this is actually difficult. It requires some analysis of examples, some guessing, some intuition. But now let's say that this is true, and now we want to solve it. What I did actually is I allowed myself quite bad time complexity, and I did this in time complexity 2 at power 5. If there can be only logarithmic number of such levels, and I did it in power 2 at power level, and I decided not to use dp, where for each of those levels I iterated the parity. So I iterated a binary mask of, for each of those 5 cases, whether I will take odd number of elements. This means that I will take a single value 3, a single value 12, a single value 24, and now I can take new pairs, but I need to be fully done with bigger value when I move to the smaller value. So now what I do is I look at this and I can say, well, I have 10 numbers remaining. Maybe this is more interesting. Let's say that I choose a single. I want to focus on those cases of how many elements I take among those, such that I will take odd number from here, even here, odd here, and so on. So from here I can take 1 element, or 3, or 5, or 7, or 9. Right, and now I know that I can take here 1, 3, 5, 7, 9. I can use some formula to compute that. I also can divide. So this already tells me that the 1, 0, 1, 1, 1 gives me some sum. And I can compute up to the n-1 how many more times I can take 48. And that will tell me how many things here I should add to the answer. And then if still I'm fully within the sum, I move to the smaller values. Saying this apparently I take 9 times, and then I move on. Well, no, for 9 I couldn't move on. For 10 I could move on. So for this case, it's not possible for you to take a pair of this. But I guess in this situation, if this is a 0 and this is also a 0, then you could take 2 of those. You cannot take 4 of those. Yeah, my logic for this is slightly incorrect in my code. Now I see it. Let's see my code, but I think I know what's wrong, so I'll try to fix it now live. Yeah, so I have some unnecessary code for modular operations. I copy pasted that. It wasn't it wasn't needed. Okay. We read the input, we count the frequency of everything. Now for every x from 1 up, if x appears in the input, then I iterate powers of 2, multiples of it. So I iterate x, 2x, 4x, and so on, and I collect those frequency. Now vector v is basically this thing, like 5, 1, 4, 0, 10. This is vector v. Now I will, while the last element is 0, I pop back. I cared about the time complexity maybe. So now I have this. And now I have some logic to compute the number of ways for me to choose from this tuple. And then I multiply the answer by this value that I built. So we now need to focus on this part. The here value, number of ways, starts from 0, and here I iterated the masks of parity, and to the here value I will add possibilities. By the way, once I'm done with some numbers, I change their frequency to 0. And because of that, the total time complexity will be okay. Actually, even without that, time complexity would be okay. For every element, if you iterate how many times you can double it, the sum of such 2 at power this count should be small enough, I think. It amortizes. And now what I did here is I iterated from big values, and I computed how much extra I have before the sum, and this divided by 2 I add to here. But yeah, I think that the zeros are an issue. Should this be done with a DP? We're solving this now. Hmm. So if you take some number of those elements, it's okay as long as from those you take such subset that you will never reach this. I think I can do it with dp, though I would need to think a lot whether the time complexity is okay. This is the editorial for E. I want to take a look whether they use dp or not. So we have that pressing x twice is equivalent to pressing a switch with value to x. This we know. Choose some elements from A and call this set C. If C contains 2 or more copies of the same value x, remove 2 of them and instead add 2x. If this, yeah, and that. Okay. First, we can observe that we may classify the values of A by their odd part. So yeah, for value 3, we say it's 3, 6, 12, 24, and so on. Now, given powers of 2, how many sums can be done? We can do digit dp. And they do it linearly, which is fast. I don't participate in UCAP. When I do, it's with Radeusz, Swistak, Marcinsmu, but I'm like a backup participant. Mostly the three of them participate. There was also MNBVMAR, but he's not active anymore. Okay, so this thing we want to do with a DP. No, I will rephrase even more. We don't need to focus on this, the fact that it's a free. So remaining task, remaining subproblem is, we know that value 1 appears some number of times. We know that value 2 appears some number of times, value 4, value 8, and so on. And we have some limit. The limit I already, let's say, divided by the smallest value. Like here, if there is a limit of 100, I would divide 100 by 3, and now the limit would be 33. So now it's like count possible sums up to some limit, which is up to 100,000 or so. This is the n-1 divided by x, where x was the smallest value, where it multiplied by powers of 2 I care about. And for that, I iterated from biggest, and I also iterated the mask of parity. But for the biggest, I said if this is equal to 10, if I take 8 of them out of 10, I shouldn't allow taking this twice. Actually, also, I should not allow taking this once and this twice. Oh yeah, that's... oh, wait a moment, but I can simplify this, right? I can say that if I have 17 ones and 10 of those, I can instead say that actually I have a single one, and 17 divided by 2 is 16 divided by 2, 8, this. I think I can simply say always frequency of, well, next times x plus equal frequency of x divided by 2, and frequency of x modulo equals 2. Oh, I missed that. then we don't need anything smart, right? If using this twice is equivalent to using this once, no, wait, I am stupid. We might need to leave two occurrences. So maybe if this is the situation, what I get from that is I can use one of them, or I cannot use both unless I use this. I cannot decrease more. I think if I have 3, then I can say 2 of them I use at the same time only by combining them up to here. So I think we need to do this. If frequency of 2 times x is greater equal to, or maybe TMP is this minus 1 divided by 2. If that, I want to say that 0 I transfer. Okay, and now frequency of 2 times x minus equal twice TMP. And frequency of 2 times x plus equal TMP. We do this. Now, because if there are 2 elements, I need to leave it like that. And after that, everything will be at most 2. Except for the last element. And now it seems I can do it in 3 to the power log. The number of elements here is some kind of k, which is binary logarithm of max. And now if every element is up to 2, and I can iterate whether I use 0, 1 or 2 elements, it will be limited by 3 to the power k. But if I implement this recursively, many cases will be ignored, because you cannot say that you use both of them if you didn't use this guy. Actually, maybe even this is simpler than that. But and let's remember this. If this is a 0, or even you cannot use both this and that if you didn't use this fully. I think I want to implement it in this time complexity without DP. Or instead, I'm sure you can also do DP. Yes, indeed. I didn't say it out loud, but 3 to the power log of base 2 of max is roughly max to the power log of base 2 of 3. What's the logic here? This is equal to 3 to the power log of m of any base divided by log of 2 of any base, in particular of base 3. So this together is m, to 1 divided by log of 3, 2, and that's equal to m to the power log 2 of 3, and that's what, 1.6? 1.58, 1.59. Right, so that should be good enough. Where's my statement? And is it really possible that I will get 2 occurrences of 1? Well, yes, it is possible. 2 occurrences of 2, 2 occurrences of 4, and so on. Oh, but this is upper limit. In practice, it will be way smaller if it's recursion, where I get rid of the impossible cases. Actually, it will be way smaller in practice. So let's just implement this. I'm not going to iterate those masks of parity, no. I have limit equal to this, and now I have this vector. I for every element of the vector except for the last one, TMP is v of I minus 1 divided by 2, v of I minus equal twice that, v of I plus 1 plus equal TMP. So for example, if we have that frequency of 1 is 10, frequency of 2 is, for a moment, let's say 100, then ideally we would add 5 to this and this get down to 0, but I want to leave 2 and only add 4 here. So 8 out of 10 I take away. 2 needs to remain as positive value because it's still possible to take a single element, and getting this down to 0 would be incorrect. So that's what I do. And now all the elements here, I can say assert v of I small equal this, and this is not true for v dot back, but I don't iterate up to that. V dot back I will not touch. Okay, I now want to create a recursion that for every element except last one, it will decide what sum to take. And the parity matters. What this simulates the following. You can say frequency of x minus equal to frequency of twice x plus plus, because using x twice is equivalent to using this once. So, and where I say while frequency of x greater or equal 3. A value 2 I cannot decrease down to 0 because it would be like saying that x doesn't exist. Such tricks, by the way, are common in different knapsacks. Like this is a well-known trick in knapsack. If you have 3 elements equal to x, then 2 of them you can replace with twice x. It's common in knapsacks. I think even this while loop could be implemented here, and it's not bigger time complexity. Okay, and now iterate, let's say, from smallest, I guess. From smallest, you decide for each of them how many times you take it, 0, once, or twice. And then when you look at biggest, you will just have constant time formula for how many times you can take it. So let's have recursive function where we provide the index where we start with, the v, the limit equal to L, and that's it, I think. There is remaining limit. Now, if I is equal v dot size minus 1, if this is the last element, then this is the limit for how many times I can take it. Maybe it's a good idea to also, if it's a brute force, then let's also provide the sum so far, the sum of values. And now it's L minus sum divided by this, because at position I have this, so this will tell me how many times I can take it, not to exceed the sum. Also, I obviously minimizing with v of I. But I don't want to count the same sum multiple times. Damn it. Is it true? Oh, this is invalid. I think we need to go for dp. Maybe first I want to get accepted and time limit exceeded. I want to avoid wrong answer verdict. So what about this? If this, then I don't know, return 1, or maybe here plus plus. let's pass this by reference. Maybe with modulo. Else, I iterate how many times, not here plus plus, I need to say that the sum is possible. So actually let's pass possible sums. Sums, insert the sum, that's it. And here I iterate how many times I add the thing here. If sum plus value j shifted by I, so j times 2 to the power I still doesn't exceed the L, then you move recursively to this new value. Else break because this is too big of a sum. You run this recursion. Rec of 0, sum 0, vector v, L, sums, and here is equal sums.size. Now, is this correct? Sure. Seems so. Now I want to submit and get time limit exceeded. Also, just not wrong answer. I want to avoid wrong answer. I want to verify that this is correct. We will wait a long time for the verdict because I'm getting time limit exceeded too. So it's wrong answer and time limit exceeded. Not great. I think I might need a brute force and local stress testing because I'm passing the samples. Let's see what I did. If I get to the end, then I insert the sum. Otherwise, I iterate how many times I want to take this guy, up to that many. If the sum is okay, then I go to the next object. I add this. This should be j times 2 at power I, right? For every x, iterate the multiples in terms of power of 2. Zeros I can get rid of. This is the sum, assuming now that the values start from 1. You run this. Looks good to me. Okay, let's, in order to, because of the stream, in order to make it slightly faster, I'm going to grab a correct code for E, copy, compile, 3000 lines of code, just a lot of copy-pasted stuff, certainly. But by the way, here the solution is very simple. Now I want to create a generator, unless I already have it. What do we have in the inputs? NM. Okay, good. I have a generator. Now a script. I want to save here. I want to diff file my program E versus his program. Okay, found a mismatch. Let's try to minimize the size of data. No counter test, 3 and 3. Found it. So just a test with 1 to 2 is invalid. Oh, good point. I don't know if he uses AtCoder library. I don't remember if I installed it on my PC. Solve problems. Solve easy problems. Read Competitive Programmer's Handbook. Now here the frequencies should be 1 and 2. Let's write the debug information. L is equal to 2. Those are the frequencies. This is the frequency of 1. This is the frequency of 2. And what I can get the sum of 0, the sum of 1, the sum of 2. Is just this invalid? Huh. Wait for... Why is the answer 4? Well, it's just 2 independent bits. I can add 1 or not. I can add 2 or not. So this is like 0. This is like 1. The limit is 2, so it should be good. Okay. For n equals 3, the length, we start from something like this. If we shift by 1, we have this. If we shift by 2, we have this instead. If we shift by both, we have this. So it's all possible. Now I have the limit for the sum to be 2. Wait, so my lemma is not fully correct. Yes, this is good. This is by 1, this is by 2, but in terms of both, they do not add up. Should I just say that the length is n, not n minus 1? Also, if I instead, let's say that the values in the input were 1, 2, and 4. If I have something like this, then I can shift by 1, 2, and by 4. And those are independent events. Why would the sum matter? Twice using a value 4 is like using 8, and that's irrelevant. Twice using 2, it's like using a 4 once. So here, n minus 1 here is equal to 6. But it doesn't hurt to use 1 and 2 and 4. But it's not valid to twice use 4, because that would exit if I had two 4s. then we would be here. But 4 plus 2 does not exceed. So 4 is okay. 2 plus 4 is okay. 4 plus 4 is not okay. But this is like just using 4. 2 plus 2 plus 4 is not okay. Also, even for 5, this would still be true. So this for the sum, only if you twice use a smaller number, it contributes to the new sum. If you use it once, it doesn't matter, it seems. If you use it 3 times, then is it like using it once? Yeah, it's not that simple. What if I simply do this? J divided by 2 times 2. So only this. Well, even worse. Oh, because that destroys... I count different sums, and now this is a completely different sum. For the sake of the stream, let me cheat a little bit. So we have this. Given some numbers, each of which is among that, up to 2 at power L minus 1, how many distinct values that are at most 2 at power L can be formed as the sum? Why at most 2 at power L? Why 2 at power L? Also, why AtCoder regular contest is so hard? Why do I need to think with editorial to fix my solution? I still think that my contest solution was 80% of the work done. So let's say we have simply this. I can shift by 4. Let's say that we have few 1s available, few 2s, few 4s available. If I shift by 4, then this will be on. If I shift by 2 and by 4, then this will be on and this will be on, which is distinguishable. I should compute that. Right. Oh, really? I didn't know about that. Which category was this contest? I can also maybe get back to my idea of counting only this. Okay, so what's the limit for the sum? It seems that here the sum cannot exceed 8, but why? And what if this is the case? And I have a lot of 4s. Well, I can collapse the 4s to actually get 8s and then 16s and so on. If something is bigger than n minus 1, then I completely ignore it. So 16 is longer than that, then I erase. I can have a lot of 8s. Oh, interesting. If I have a lot of 8s, And I either can change it, I still can change two of them into 16, and I continue. And one more final fix is that if a number is bigger than n-1, then I can erase it. So even if I have 10 8s for something like that, you can get rid of most of them. Which means that in my solution here, when I said that vi is smaller or equal to, then actually it's true for all the elements if I implement this properly, including the last one. Oh, and this is the medium difficulty, okay. Now, if I did this logic, now, is it true that I can not care about exceeding n-1? But if I use 2 4s, I cannot achieve any 16. 16 would be bad. So do I need to find next power of 2 after n-1? So n-1 is good, because from here you can shift by n-1 to be here. Any power of 2 above that is greater or equal n is not good. Seems so. So the sum should be smaller than that. Well, let's implement that. Still, let's say with a brute force. Here, I want to control Z this. So L is not that. I want to say that there is this. Okay, power is equal 1, while power is smaller equal than L, power times equal 2. And now this is bad value, first bad power of 2. I will here pass the power, and I cannot achieve that. So if it's smaller than good, now it works. Let's increase the size. It works. Let's speed this up. I want to improve the last value because there can be a lot of stuff. Where is it? So here. I have that frequency. Did I erase my logic? Did I erase part of my code? Yeah, I think so. Oh, it's here. Now you iterate, and always that many you push forward. Now this should still be correct. Now I will iterate up to the last element and possibly keep expanding. Now if TMP is greater than 0, so if I have something to shift, I do this. Now if this is the last element currently, then V pushback 0. So now if needed, I fake create bigger values. Still works. And now all values are up to 2, so the time complexity is 3 to the power something. And well, let's submit. Hopefully now I get only time limit exceeded. Mm. Yeah, I think so. A lot of people good at CP trained math. Yes, those are related. How can I train math? It's hard for me to say. I was in that convenient situation. No, not wrong answer. Stupid AtCoder. So wait. This works here. Let's say that x is a random element among 2, 4, 8, 16. This will be stronger in terms of random randomization. Or just let's say 1, 2, 4, 8. N is up to from 9 to 20. Random element here, and next 4. I passed almost everything. I have 4 wrong answers, which is strange, and only 3 time limit exceeded. What if I here say 3, 6, 12, 24? AtCoder is better. Yeah, AtCoder. Is this as difficult as code problem A? I don't remember, sorry. Well, it's hard to stress test it because it's hard to create strong tests. Is it possible that I have something like an overflow? But faster I would run out of the set size. It's wrong answer. Is it possible that I inserted billion elements there? No, memory would be bigger. Speeding up would be easy, I'm sure. I would even, maybe just I replace set with global boolean array, and that already would be good enough. Right now the time complexity is of, I think, max to the power 1.6. But that can be improved with DP. But I don't understand what is wrong. I don't think there is a way for me to get this test. Powers 1. The name suggests that just powers of 1 are in the input. I think it's a simplification of a name. I think it's 3 multiplied by powers of 2. But still, I have wrong answer on powers 1. So I'm guessing 1, 2, 4, 8, and so on. Powers 1 certainly doesn't mean powers of value 1. It's like 1, 2, 4, 8. Hmm. What is wrong? Maybe this division. This tells me how many times x can be multiplied to not exceed the length. Here I find the next bigger power of 2. If this is 7, I will find 8. If this is 8, I will find 16, because such a power is not available. And then we make this. This is not good. I don't know if there is such a way in AtCoder. You can maybe from every AtCoder beginner contest solve A. I'm not sure. Okay, I think I... Maybe, no matter what, let's make this faster. If I took 2 of the previous element, then here it's not allowed not to take something. Bool took 2 is equal this. If I took this, now here j greater equal to. If I took at least 2 elements, then the next thing needs to be taken fully, right? Yeah. If also long for safety. Took 2, if so v of I, otherwise 0. It's not allowed to take it's not allowed to twice take x and then to not take twice x. Instead, I want to say instead of 2 of those, I do this. That will get rid of time limit exceeded. By default, we run this with false. This, I think, improves time complexity to linear. Let's submit and see what happens. Okay. Oh. Was the mistake here? Let me copy this. Was the mistake the lack of long in the bitwise shift? So if I submit this, and here I do cast to long of j, is this enough to... Now, this code got wrong answer and time limit exceeded. Will this be just wrong answer now? Okay, so some kind of overflows caused the program to slow down. Got it. So this is 3 to the power something, this is 2 to the power something. The something being logarithm. So this is linear and this is roughly n to the power 1.6. Okay, got it. Oh, a lot of time. Also my throat hurts, too much talking. E, solution summary. Finally. You know, it's not enjoyable, this process, if I don't know how far I am from valid solution, But if eventually I spend time and I actually fix the issue and I get accepted, it's so satisfying still. I'm not really competing much anymore, but there's still happiness and satisfaction from getting that accepted in a problem where you struggled for a long time. Okay, solution summary. We quickly understand that the order doesn't matter of operations that are described in the input. So it's just about taking subsets of given A values. And we want to count how many really different subsets there are in the input. And turns out if AI is equal to another A of j is equal to 3, the usage of those is independent. And always, whether we use one and whether we use the other will affect the least significant bit, and because of that, they do not affect each other. For example, if there is nothing smaller than them, then if this bit is 1, then you used this guy, and if this bit is 0, you didn't, and same thing here. Just by looking at those two, you will decide the fate of those two guys. The thing is not that simple for if one thing is double of the other. In particular, this is easiest to analyze. And here in particular, if there is another thing equal to 1, then twice using this is equivalent to once using that. If you have this final binary string, possibly it came from using this, or possibly it came from using this, both of those. Now, we use a trick similar to knapsack. Oh, and we can understand that actually then different powers of 2 are important. So if you collect all such elements from the input, they have some interaction with each other. For each of them, you count how many times it appears. And if you see that 1 appears, let's say, 5 times, 2 appears 100 times, 3 appears some number of times, and so on. Sorry, not 3, 4. What you do is a trick from knapsack, where if you know that 2 occurrences are equivalent to the double thing, then 2 of those I can change into 1 of this. 2 of those I can change into 1 of this, and so on. Now you can do the same thing here. 2 of those you change into 1 of this. Having 2 values in the input equal to 2 is equivalent to having 1, 4. You keep doing that. Eventually you will get, let's say, 1051, 852, 653, 454, 5. What am I doing? Once again, 852, 653. Just a while loop where we decrease this by 2 and increase this by 1. 4, 4, 2, 5. And here, be careful, you cannot decrease this down to 0. You cannot say that it's like having 0 elements of this and 1 of those, because this way you make it disappear the possibility where we use a single of this. So now we leave it like that. The logic is, while frequency of x greater equal 3, frequency of x minus equal 2, frequency of twice x plus equal 1. That's what we did. Even if you can just implement it like that, it will work. I used formula to do it fast. Okay, so every value will be in range from 0 to 2. And eventually, if you get this way some power that is way bigger than n, the length of the binary string from this task, then it doesn't matter how many times it appears. So maybe can be ignored if way bigger than n minus 1. We will specify what way bigger is in a moment. Now, if you have logarithmically many values here, like let's say log is around here, I don't know, 17, then we're talking about time complexity 3 to the power 7. If for every element you iterate how many times you will take it, 0, 1, or 2, with like recursion. But actually, we can do dp, and what I did is kind of similar to dp, just I did recursion and I was lazy, where we can for every object iterate how many times we take it, 0, 1, or 2. And if we take 2 of those, we don't want to say that this one I take 1 occurrence out of 2. That's not allowed. Let's say that instead I would take, it's better to take 0 of this and then 2 out of those, because every case I want to count only once. So with such speedups, instead of 3 to the power 17, you can get 2 to the power 17, and it's of linear total. If you do that, though, and eventually I did something that I think achieves that. And one way of implementing then is just thinking how many different sums of those values I can get. But the sums, if they are big enough, if they exceed some power of 2, they stop mattering anymore because they do not fit in a binary string. For example, if you start with this binary string, if you use a value of 1, 2, and 4, all of this is visible. But if you now use another one, it will overflow. Because now using another one means that this will collapse to here, this will collapse to here. Actually, what happens if now? Oh, I didn't process this fully. If you use 1, 2, and 4, you will have this string. If now use another one, what you will get is 1, 0, 0, 1, but this first one doesn't exist. So actually you would get back this. So this is fine, but if you add another one, it overflows. So this starts overflowing, and you actually get something that is equivalent to a smaller subset if the sum of values becomes 8 or greater or equal 8, where 8 is the next power of 2 after n. So this is your limit. And one possibility is then to do dp or some recursion where you try to take 0, 1, or 2 out of every element, you maintain the sum, and you wonder how many different sums you can get. Different dps should be possible, going from biggest or from smallest, but what I did is just lazy recursion. One more thing is that in my implementation, I used here a set, which is not very efficient. I will show you now a trick for this to get rid of logarithm, and then we'll do, I will stop the stream. There is this trick. You make global Boolean array of some big enough size. Here, instead of this, or maybe I will pass a vector because I'm lazy. And I also will maintain the count of different values. And how can I use vector instead of set? Here I will say, if not, let's say yes. If not yes of sum, then sums push back the sum, and yes of sum is equal true. So this, with Boolean array, you make sure that your vector will not repeat stuff. Do I need count? No, I have vector size. Okay, and here after you run it, this is a vector. After you run it, additionally you iterate the vector and you clear. Overshadowed y and y. I got rid of the logarithm in time complexity. I will submit now, but I don't know if we will get something better than 150 because I don't know which part was actually a bottleneck. But maybe we will get now better runtime. No, it's not 2 at power. Well, yes, the sum of powers cannot exceed 2 at power n indeed. Right? No. No, 2 at power n would be huge, enormous value. N is, if n is 100, then the sum cannot exceed 128. What do you mean? What are my thoughts on him? He's a person. What thoughts can I have on him? well, if you're into competitive programming, I think it's fine to use defined int long. I'm an adult who also might sometimes have a normal job, and then I want to use the proper types. But you can use defined int long. Also, why was this needed? I thought that when we start iterating from 0, I think this could earlier get as big as the sum of values in the input. Oh, here I also have an overflow. I mean, some imaginary overflow. Okay, I understand what happened. If in the input I have multiple times, I can have, let's say, 1 million, and that I have many times, then what I do is, I don't here explicitly do it, but I say, oh, instead of that many times, let's say this times m, then instead I can say 2 million, I can have that many times, and so on and so on. And eventually, this will represent values as big as million times million. And they are not computed here. It's just that v of 0 corresponds to 1, v of 1 corresponds to 2, and so on. And I will get as high as v of 40 with this logic. I will get to v of 40, and here I got wrong answer, and also time limit exceeded, by the way, because I got here to I equal to 40, and even 1 shifted by 40 will give me something stupid, like 0 or negative value, and this is why it was incorrect. Got it. Right, so I struggled a lot with E. Certainly it shouldn't be treated as the proper way towards the solution. I'm also sure that the editorial is more structured in how they arrived there. Plus, I also was lazy, I didn't do digit DP. So in app solving, I recommend that you try to, now forget about my solution for E, and you try to use your digit DP, which will be an important practice. I just wanted to finish the solution from the contest, the solution that I have. I'm not happy with the fact that basically all of this I had during a contest, and then I needed more than 1 hour extra. But what can you do? Okay, this was way longer than I planned, but I hope you learned something. And I will again remind you of the Olympiad classes. So together with Harbor Space, I will teach for the next months, I will teach 2 groups at Olympiad level classes. If you're in high school or below, you can join for free. All the details are in Codeforces, including the registration link. The easy group will start very soon, maybe tomorrow. The hard group will start in 2 weeks. Here's the link. Olympiad classes. Oh, I need to also put it in description of YouTube recording so that later people could find it. Digit DP, I don't know, maybe one day. Yeah, the classes are only for high schoolers and below, sorry. There is YouTube where everybody can learn. Okay, no more AtCoder this week. I don't know if I will do the same thing next weekend, but it's clear that regular contests can be difficult. Thank you for watching, everybody. See you in around 2 days, I think. I will do some live stream problem solving. Okay, bye-bye.